I'm Mike Lepech. I'm an associate professor of civil and environmental engineering at Stanford and director of the new Stanford Center at the Incheon Global Campus. My research focuses on multi-scale sustainable built environments and smart cities, and how we can use smart city technologies and the smart city paradigm to achieve more sustainable built environments and a higher quality of life for everyone living in cities of the future. Tomorrow, we open the Stanford Center at the Incheon Global Campus. This is Stanford's flagship research center here in Korea. We're super excited to start all kinds of collaborations across the country. The focus of our center initially is on smart cities, and located in the smart city of Songdo, this makes a great deal of sense. Our first few projects will focus on how to collect, store, and visualize smart city data. What kind of hardware will we use? And what kind of technologies will be necessary to be able to scale that kind of data collection and visualization? In addition to that, we're very interested in how different types of infrastructure can be integrated together using that data to improve their overall performance and the services that they can provide to people living in smart cities. Examples of this include trying to couple the water system and the energy system. All around the world, water and energy are two of our major problems. It takes tremendous amounts of energy to treat, transport, and provide clean and safe drinking water. It also takes lots of energy to treat that water so that it can be returned to the natural environment. So how can we use some of our renewable energies and other types of energy to harvest throughout the urban ecosystem to more effectively treat and supply safe drinking water? This is just one example of the ways that we can connect together infrastructure systems in smart cities of the future, like mobility and buildings and energy, transportation, and all kinds of other infrastructure systems. Our third project focuses on entrepreneurship. We know that Silicon Valley was created based on a tight collaboration of startups all working on a similar type of problem. In that case, silicon chips, the foundation of modern computing. So we think that potentially the infrastructure that's been put together in a smart city can serve as that same foundation for startups working together to be more competitive and more successful on a global scale. So we're really interested in studying how we can think about new companies, new product ideas for smart city citizens, and also using data off of those same smart cities to speed product innovation and make things go even faster when it comes to new startups and new ideas coming into market. Our fourth area of focus is on municipal finance. Smart cities are expensive cities. How will we pay for these in the future? And what can we do to try to boost municipal revenue so that we're not always increasing taxes to pay for these very expensive infrastructure systems? But I also mentioned that this is Stanford's flagship research center and is there for the entire university. And so we're looking forward to branching out beyond simply smart city research into areas of precision medicine, as been led by our medical school and our dean of medicine. Whether it's working with the human artificial interface, HAI, or the Stanford Design School, D School. We're going to be doing all kinds of exciting research at the newly opened Stanford Center at the Incheon Global Campus. And I hope every one of you is going to be involved. Specifically with regard to this project, I'm really excited to begin working with the Jeju Smart City Challenge Consortium that's been led and initiated by GS Caltex. This is really a very unique and exciting project because of the opportunity for Jeju Island to be fully electric and potentially fully renewable in the very near future. This is the way that much of the developed world will have to go in order to truly make a difference when it comes to our climate change crisis. And it's essential that we figure out these problems and how to surpass these challenges in a collaborative and very focused way. And that's one of the things that I'm most excited about with regard to this project. It's truly providing a pathway to solving our global climate crisis, and one that is hopefully repeatable and scalable on a worldwide scale. It is truly exciting. I think there's also some very interesting things about Jeju that make this a project really interesting. There are roughly 190 gas stations, and by 2030, over 80% will be transitioned to EV charging or hydrogen refueling stations. That's exciting, that's scalable, and that makes a real difference as we think about, once again, that global climate crisis that we are all struggling with together. And so, with regard to my research, I think there's a number of projects that we're working on at Stanford and also at CIGC that will specifically relate to this project. Two of them are about, one, renewable energy, and second, how to integrate renewable energy technologies into our building ecosystems. So the first one, on renewable energy, is introducing completely new ways to think about managing renewable energy, electricity, from renewable resources that can boost the reliability of local microgrids. And that work, being done by one of my PhD students, Wei-Xin Gao, is really rethinking the way that we think about reliability of microgrids that are powered primarily by renewable resources. And when it comes to the Jeju Island Smart City, absolutely, this is a technology that can be used. The second is work that's looking at integrating revolutionary energy systems with building systems. And this really builds off of portfolio theory from modern finance. So in this case, we'll look at a community as a collection of buildings, all of which are consuming energy, heat, and electricity at different times of day. Of course, residences, they start to consume energy early in the morning, and then as you head off to work, we see that energy consumption drops down. And then when you return from work, that energy consumption goes back up until you go to sleep at night. And then it repeats again the next day, at least for weekdays. Of course, offices, they start to ramp up right around the start of the workday and stay high until that end of workday. And then when it comes to things like hospitals, they're pretty much 24 hours a day, 7 days a week, 365 days a year. For heavy industrial facilities, it's a little bit different. And for entertainment facilities, like theaters and other types of entertainment facilities, restaurants, they start to really ramp up later in the day and go late into the night. Weekends are also big for them. So one of the things that's most important when we talk about any kind of reliability in the power system is that we need to always match demand and load, because we want to make sure that each one of those two things are always equal. And so in this case, what we're thinking about doing is, how do we design a city? How do we place the buildings, and which buildings do we design together to be able to, when we combine each one of those energy profiles throughout the day, that we can then match that overall energy profile when we add all of them up for the entire city to the kind of energy we can produce from renewable resources and non-renewable resources as we combine those two things together. So we're always matching supply and demand of energy resources. That's another example of how we can start to integrate infrastructure systems together, in which we're actually designing the buildings and the communities to match the energy that they have. Historically, we've always just simply said, we'll build what we want and we'll create enough power to power it. And this has led us to where we are in terms of a global climate challenge and an unsustainable urban ecosystem. Rethinking the way that we design our cities to be smarter and more responsible when it comes to energy consumption and their operations, and matching them with the resources that we actually have, is going to revolutionize the way that we think about what a smart urban system looks like. We're also doing work in my group on thinking about the use of autonomous vehicles in order to help us control the operations of a city. Autonomous vehicles are amazing groups of sensors that move all around the city. They're collecting tremendous amounts of data about where we are, where we're going, and what we're doing. And yet, that data, for the most part, is ephemeral. Well, can we somehow use it to help control traffic lights in a much more efficient fashion to get you and I where we want to be faster? Can we use it to better understand traffic patterns, to optimize the operation of cities? Can we leverage smart, autonomous electric vehicles as platforms by which we can collect data and transmit signals and new information to the smart city around us? Those are just some specific examples of really exciting research that's ongoing at Stanford, in my research group, and very soon at SCIGC. And I'm really excited about the potential for the collaborations that are going to arise from all of these different aspects of the project. So in closing, I want to say how excited once again I am to be part of the Jeju Smart City Challenge Consortium that's been initiated by GS Caltex. And I also, going forward, want to welcome every collaboration across Korea to bring Silicon Valley together with all of the innovative things that are going on here, because together we can truly make a difference when it comes to some of the world's largest problems that are confronting cities and the entire world as a whole. Thank you, and I'm really excited once again to start this project.